talk about web scraping.
Yeah, I've seen some fun things where people will like take stuff from wikis of how often people show up in episodes of cartoons and things like that, and then use that to do some analysis. And so that would be fun. But now we're live, and so everything we're saying is being recorded on the World Wide Web. All right, there we go. All right, I just posted the link to the article that we're going to go through today. So welcome to UAB Data Science Club. I am William Stonewall, and this is Robbie, and we are going to talk today about what to do with data that you find lying around on the internet, or maybe the types of data that you can find lying around on the internet, especially from like news sources.
Yeah, this is important. If you are new to data science and you are looking for data sets that you can work with to improve your algorithms and or understanding of the algorithms that you would be implementing, it's essential that you can find free data that's lying around on web. And we are going to show some methods of how you can, when you find that data, how you can pull it back in your Python scripts and run analysis on it. There are various other methods which is basically just known as web scraping, where you go and get data from websites and convert it into a data frame of your choice for the analysis. But the main topic that we are going to be discussing today is a lot of websites already have data in the form of CSV, which you can download and get into Pandas data frame. And that's basically what we'll be discussing today. Maybe next week we might go into web scraping a bit. And that's what William and I were discussing at the beginning of this video. I think, because we thought that would be the main crux of this article, but it's basically just that you have some data on web, you're just pulling it down and running some analysis.
Mm-hmm. All right, so let me go ahead and share my screen. Desktop, here we go. All right, and then we'll go over here. All right, so for the analysis part, we're going to go to rc.uab.edu. I'm going to open interactive apps and start a Jupyter notebook. And let's see, I'm going to start that in the rc-dsc folder that I've got. And I don't think we need a GPU today because we're just reading in CSV files. And I only need, I probably don't even need 4 CPUs and 16 gigs of RAM, but we'll go ahead and start there just in case these get to be a little bit large on the dataset side. All right, I'm going to launch that. So that's scheduled. On the other side of the screen here, I've got the tutorial that we're going to look at is this one called Python for Data Journalists, Get Your Data from the Web. And I posted the link in the comments of the YouTube video that we're streaming right now. And so you can see that this is use Python and Pandas to discover, read, and analyze data from CSV Excel spreadsheets on the web. This subtitle is a little bit misleading because it looks like it's saying that you can use Python and Pandas to discover data from the web. But really what this is saying is that this particular article is once you have data that you've downloaded in CSV and Excel spreadsheet form from the web, you can use Python and Pandas to discover trends and read and analyze that data. There are other things you can do to actually scrape or generate new data from websites like Ravi mentioned, but that's not what we're talking about today. All right, so I'm going to start up my Jupyter notebook. All right, and we'll just create a new folder. Oh, let's see, new folder, and we'll call this folder. Where did my new folder get created? Let's see.
I think it gets called untitled, right? By default.
I think so, yeah. Untitled folder, here we go. So I can I rename it?
Yeah, there is a, yeah, if you select that and go up, there's a rename option.
Oh, rename, there we go. And we'll call this data journalism, which data journalism is just a fancy name for data science with news type data, I think. That's probably not the best definition, but it's what we'll work with for the moment. It's very, very related. All right, so now I'm going to use the NBOTW, the Notebook of the Week environment, because as far as I can tell, we only need pandas and Python to run this code. All right, so I'm going to scroll down here. So, okay, if we're a journalist, we want to tell a story. And if you tell a story with data, then you're doing data journalism. And so we're going to find some open data. And what this is saying is that a lot of times data that you may be interested in is potentially open, especially from government sources. And so the key is just finding those government sources and then figuring out how to download them. And so it'll show us a little bit on how to pull those. This is about setting up Jupyter for data visualization. We don't need to worry about that right this minute. But first thing we need to do is we need to import our pandas and matplotlib for visualization. And we might go ahead and also import Seaborn. Seaborn is another visualization library, and a lot of times it makes prettier graphs than the other ones. So yeah. All right, so first thing that we need to do is we need to download some data. And so we can do that here by clicking on this link.
Do we want to call it directly in pandas?
Oh, can we do that directly in pandas?
Yeah, I think pandas can read directly from a URL.
Okay, so if I go do pd.read, is it HTML? No.
Maybe let's try that.
It might be, we might be able to do read CSV too. CBF equals. All right, so that was an import error. LXML, okay. Let's try, because it does actually download, when you click on that link, it does actually make a CSV file.
Yeah.
Okay, so that didn't work either. Forbidden. Okay.
Let's search pandas.
Oh, it's because it's generating a CSV. There's not a CSV that's already there.
Oh, okay.
So when I click on this, it's generating a CSV. The new name. All right, so if I save that there, Then if I come over to, let's see, I think I got to come to files. And I'm going to go to my data user US Monroe RC-DSC. And
Data journalism.
Data journalism. All right, then I can upload that file from my desktop. Okay. All right. So now it's there. And so now we can read that CSV file. And it's called series 270520. So it looks like it's named with whatever today's date is. Okay. All right. So now we can look at that. The top of that file. See what the first few lines look like. Okay, so the United Kingdom population mid-year estimate. Oh, let's look at the first 10 rows so we actually start seeing data. Okay, cool. So it looks like it starts in 1971. Okay, and oh, here we go. So we actually want to, when we read it in, we want to skip the first few rows to avoid reading in this metadata as part of our data. So let's see, so series, skip rows 8. So that'll get us to row 7, maybe, we'll see. And then names. All right, so this is just saying, what do we want our column names to be? We want the first one to be year and the second one to be pop for population. And we don't have an index column. So let's try to look at that. Okay. That looks like that worked.
Mm-hmm.
Okay. All right. So now that we have that, we can actually plot it. And so we can do SNS dot, I think we do a line plot of, let's see, we want X equals the year
and Y is
and
pop.
Y equals pop and data equals data. Oh, what I do wrong? Could not interpret year. What is it? Let's see, data.info. Oh, that's interesting. Oh, it's because my index column is year. Let's try this. There we go. There we go. All right, so what happened was when we imported the CSV file, we made our index the year column. And so it didn't, the pandas data frame didn't recognize that we had a year column to use for our X axis. All right, so yeah, so that's the UK population by year. And yeah, and so now if we wanted to, we could, see what the difference between today's, well, I don't think we've got 2020 data in here yet.
2019.
Oh, no, we might, but for some reason this article has bad quotes. It's got like the Microsoft quotes in there. Yeah, but you're also right. We need 2019. Oh.
So only till 2018.
Maybe 2018. What's going on? Key error.
Just search. What's the last?
Oh, it's because I did this thing and took out that as the end index.
Oh.
So it would have to be data pop where data year equals that. I think this will work.
Yeah.
No, that's still not working. All right. Here, let me just put back the index.
Daddy, can you take off these keys?
I have small people coming and asking me questions.
Maybe in
Okay,
SNS.line plot, maybe if we don't specify X and Y, just the data.
Just the data. Okay. Oh, look at you go.
Yeah, it's.
Yeah, there we go.
And we might have 2019 here as well.
Yeah, let's look. 2019.
Nope.
No.
All right, so we only have to 2018.
Yeah. All right. But we got the same answer, so that's good. All right. And so then we can see like percentage increases over the years. Let's see if we look at that. Oh, they're darn single quotes. Let's switch this out. There we go. Hey, there we go. So the population increased by almost 19% from 1971 to 2018.
It's not bad.
Perfect.
Actually.
Yeah. All right. So let's see. So there's a second data set here. Let's see. From the UK Parliament. Oh, okay. So here we should be able to let pandas just read it directly from the URL. So if I go, I guess we'll just copy this, but then we'll pop this URL in.
Yeah, maybe just yeah.
Maybe just what?
I was just thinking maybe just have a variable called URL so that we don't have to copy.
Oh yeah, we can do that. Let's just do that because that's a good idea. There we go. Oh, once again with the quotes. So, interesting tidbit about reading in Excel data. Oh, apparently I need to install something to get full Excel stuff. Pandas will by default only read in the front sheet of the page, and so you have to specify directly which sheet you want it to read in because it will only read in one.
Oh,
It's not going to read it all in and then create some kind of multi-page data frame. All right, it looks like I need XLRD. So let's come over here to our terminal. All right, module list. Do I already have an? Yeah, I already have Anaconda on. So Conda activate BOTW. And let's see. So we need to do Conda. Is it list? And then just grep XLRD just to see if we already have it installed, and for some reason it's just not working.
yeah.
Okay, so it's not installed. So then what we can do is we can just Google Conda install XLRD. And it should be pretty straightforward. Yeah. I think if we just did Conda install XLRD, it would work. Conda install XLRD.
Yeah, I'm pretty sure Anaconda channel is there by default.
Yeah. It's thinking. It's thinking. So this XLRD is just, I'm assuming it's just a Python package to extract data from Excel spreadsheet files. All right. Yes. Okay. Dun, 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 dun. All right, so it's on there now. So now, do I need to restart my kernel or should it just be there?
It should be there.
Let's see. So that works now. Expected 7 fields in line 4, saw 8. That's interesting.
Yeah.
All right, apparently we need to download this file and take a look at it. Something is a little goofy here. Okay, so we want the summary. Let's see, so that's 1, 2, 3, 4, 5, 6, 7, 8. Not really sure why it says that it's expecting. 7, but I got 8.
What was the error message again?
It's a parsing error.
Yeah.
It said it expected 7 fields in line 4 and saw 8. Let's see if we... No. All right, let me see if for whatever reason, if I upload it, it should work the same. So I'm going to be kind of surprised if it doesn't give us the same error. Okay. Just going to comment that out. And then we'll just keep the name of the Excel spreadsheet. And we'll try that again. And yeah, it's giving us the same error. Saw 8. Header equals 2. So header would be which row the header actually is on, I think.
Yeah.
So
So the
let's
first.
look at that. What if I go, instead of 2, I say 4?
Yeah, header should be 4 and anything after that. So I might be skipping the first few rows.
Let's try that. Oh, there we go.
Yeah.
Apparently it is 0 indexed. Even though, oh.
Yeah, it's. So it looks like they have changed formatting since the time this person wrote the Medium article.
Yeah. So let's see, because it's 4. Interesting. Because this, if I do 4, it takes that wrong row. If I do 3, it gives me the same error. It's expecting 7, but saw 8. And this is where sometimes doing a little manual data cleaning is what's going to help us out. So if I come in here, I don't think I need this first column for any reason.
No.
And then I'm just going to name this first one for kicks. And I'm going to resave it. And I'm going to re-upload. Now, if I was programmatically uploading this data in every, every 30 days or something for a continual, I don't know, some kind of editorial data journalism thing, I would figure out how to automatically import that without having this issue. But if we're just importing a historical data set once for the purposes of writing an article, then it probably makes sense to just fix your spreadsheet. Let's see. All right, so now my header should be 0. Yep, there we go. And then my index column is now 0 because it's the year.
Here is the, yeah.
There we go. All right. Okay. So now, if the rest of this should work, except for the nasty quotes. Okay. Let's see, what's...
Oh, we might have to change some of these values. iLock, here is to minus.
All right, so iLoc, so we're one back from the last row.
So -1 is okay, but we don't need 8. It should be from 1, right?
Because this is saying from 8 to -1. Oh, because it's saying I want the population. Oh, the population, I'm adding, I got it now.
So only from 1971.
So I'm adding this immigration data to my previous data frame. Let's see. And let's see, why is it 5? What's 5? Oh, this is saying, I understand now, because this is the row index.
Yeah.
And then this is the column index. So this is where I'm getting tripped up, because this is the column index should be 0, 1, 2, 3, 4, 5 is what it should be. But I think because we've already put our index here, let's see what happens if I change this to 4. Okay, that doesn't look right.
No.
Oh, night, because all right. Because 1972. Oh, no, 1972 is correct. Let's see. Let's start at 7. There we go. That's what happened. That looks right now. Because we've got 40,000, 11,000, 50,000. Okay. All right. So sorry for that confusion because of the different way that we imported our data. When they imported theirs, it looks like they kept the column names as the first row. So instead of starting at row 7, their year 1971 starts at row 8. Ours starts at row 7. And then because we don't have that first NaN row, our net migration is in column 4 instead of column 5. And so what this is doing is saying, hey, take the data at the same index locations or from the index locations from row 7, column 4, all the way to the end, except for the last row, and put it into the data frame that already has the year and the population. Okay. All right. So then if we keep on going. All right. So now, just like before, we can do a SNS.line plot of our data. And that plots them on the same thing. But I think if we just do y equals
M.
Oh, come on. Oh, can I specify x equals index?
Maybe.
Let's see. All right, we need to, all right, so Seaborn plot with x axis equals index.
Or it should be df.index or data.index.
Oh, okay. So let's see. Here we go. Okay, perfect. All right, so now, okay, so we're just going further down the rabbit hole. So we're taking our immigration as a percentage of our population. And fixing all of our erroneous single quotes. Okay, so now we've got the percentage of population that was immigration. And now if we plot that, it's basically going to look the same. It's just going to be normalized by the population. Yeah. And okay, so this is where we can do a scatter plot. Scatter plot of x will equal our population and y will equal our immigration and our data equals data. There we go. And so we've got that. I also like sometimes the I think it's the dist plot. Oh no, that's the histogram. What is it? Is it a density plot? Trying to remember. Well, so if we do a dist plot, then that takes just a single one. So like, will that take in data? No. It's, I think we put in data dot pop, for instance. Yeah. And so then that shows us our distribution of population, which is nice. All right. And let's see. I want to look because there's a fun plot that you can do where you do density plots on both axes.
Mm-hmm.
let's see. Here we go. Joint plot. That's what it is. Because that kind of combines the histogram with the scatter plot. There we go. Perfect. Okay. All right. So all that to do about data, but the real key factor here is if you're interested in some data, there's a reasonable chance that it's out there and it's publicly available, and it's super easy to read in data from an Excel spreadsheet or a CSV file into pandas and start playing around with it. Other thoughts, Robbie?
No, that's basically it. I would echo what William said, that a lot of this kind of data you should be able to find from government's websites, and especially in US, it's basically like all of this data is publicly available. So if you want to utilize it to make some graphs or improve your data science skills, you should be able to do so.
Yeah. Yep, exactly. Well, we kind of took off a couple of weeks between the semester break, but I think we're back to doing these once a week. So we will see you guys next week.
Right.